This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. In the previous session, friends, we were discussing about the second level of optimization inside the Hive, and that was nothing but once we are going to query onto the tables, then we are supposed to apply certain optimization technique, and that will provide you decrease in the latency, or what I can say, you will be able to optimize your job. So query level optimization, over here inside the query level optimization, what we have seen, that is map side join. Over here we are just talking about the joins. So we are having certain tables, and on top of those particular tables, we are going to apply these particular joins, and these particular joins are going to provide you the benefit in terms of latency. Okay, so map side join was working perfectly once we are having two tables, and one table is the bigger one and another table is the smaller one. And the condition over here onto the map side join, the small table must be small enough in order to fit inside the memory of a particular node. So at that moment, map side join was working perfectly. Then moving further, what we have seen, bucket map join. Bucket map join. So once we are talking about bucket map join, it is the join which is applied once we are having two tables and which are big in size. Okay, any table is not able to fit inside the memory, so at that moment we are going to opt bucket map join, and based upon the bucket map join we will be able to have the optimization. Proceeding further, we have seen SMB, that is short merge bucket. Short merge bucket, and short merge bucket is, it is also applied once we are having two tables and both of the tables are big in size, and no table is able to fit inside the memory of the node, so we are proceeding further for the short merge bucket join. And the condition with respect to bucket map join and short merge bucket, that is you are able to see over here, so bucket map join is applied. hmm, hmm. Okay, so bucket map join, once we are having both tables in a big in size, and both tables must be bucketed onto the join column. And the second condition with respect to the bucket map join, the number of the number of buckets in the second table, for the second table, that will be integral multiple of first one. So this is somehow different from the short merge bucket. The first condition is same, and along with the bucket or along with the bucketization onto the join column, we are going to perform the shorting as well. We are talking about short merge bucket at this moment, so we are going to perform the bucketization and shorting. Second thing, number of buckets in both of the tables must be equal to each other, that is with respect to short merge bucket, so we have seen these three techniques, that is part of query level optimization, and it is applied once we are having two tables and we need to query, we need to do the analytics on top of those particular tables. That is perfectly fine. And this was the second level of optimization what we are having inside the Hive. Moving further, the third kind of optimization or third level of optimization, we used to say syntactic sugar. Syntactic sugar. So over here, like, it is not going to provide so much benefit in terms of latency, but it is going to ease the life of developers. Okay, so we used to say syntactic sugar, or certain syntax are there, certain functions are there, which we guys are going to have, we guys are going to apply on top of the tables, and then we will be able to get the outcome easily. Okay, and if we are talking about syntactic sugar, then first one is the ranking. Okay, Ranking, as the name is indicating itself, say we are having certain data, and on top of that particular data we are trying to find the rank of a particular value. Okay, so ranking is working in that particular way. For an example, say we are having certain students in the class, and then they have scored some marks in the data science. Say one of them is scored 99, second one is 98, third one is 97, fourth one again 99. So how we will be rank those
Hi Ashok, you are not audible.
I think he has internet issue.
guys, are you able to hear me? Are you with me, all
Yes,
of
yes.
you?
Now you are audible.
N-
Earlier you were not audible.
Actually, Ashok, in between we lost you.
Oh, I'm not checking my mobile as well, today my internet is fluctuating. Sorry for
Yeah,
the issue. So so okay, not an issue, sorry. Once again, so I was talking about ranking, so what we are having uh, syntactic sugar, and I'm on my mobile as well. If someone is facing any issue, just try to call me, okay, at that moment I will be able to get the information that I'm not audible at that moment, right? So this is the first time once like this particular internet is not working properly. Just call me at that moment, i'm I will be able to get
sure,
that I'm not
sure, sure,
audible.
sure,
Okay.
Ashok.
Okay, so I was talking about ranking, my friends. So ranking, once we are having certain data, and on top of that particular data, we trying to find the rank. I have quoted an example of school students who have scored certain marks, and based upon their marks, I just want to find out the rank. So if we're talking about ranking inside the Hive, then four types of ranking is available. So rank, dense rank, row number, and partition by. So these are the four categories, what I can say, which are there inside the ranking, and by which we will be able to find out the ranking. And both of these particular techniques are working differently. So we are having this particular data set, that is rank data set, and on top of this particular data set we will be trying to apply rank, and we will be able to get the information. So in order to move further with the practical onto the rank data set, what we are going to do, we are going to have certain steps, so with respect to the steps, what I will do, first I will move this particular data Okay, first I will try to move this particular data inside the HDFS. Okay, once the data is available inside the HDFS, then what I will do, I will create an external table on top of this particular data, and then I will be having that particular data over there. And once I create the table, then I will proceed for applying the ranking in order to check the rank for the given records. So this is the data set what we are having, ranked data set. And if we are having something onto the local and we need to move it onto the HDFS, which command we need to utilize?
Hadoop,
Which command we need to utilize?
for fs put hyphen put
Hadoop fs hyphen put.
location.
Then let me check where I'm going to put. So Hadoop fs hyphen ls, then user Cloudera. Okay, so over here I'm going to create a particular directory probably, and in that particular directory I'm going to load this particular file, mkdir, and which directory, say ranking. I'm going to create ranking directory. Okay, so ranking directory has been created. Just have a look, we will be able to see that particular directory over here. So mkdir, that is the command to create the directory, and we are having ranking directory at this moment. Now in this particular ranking directory I'm going to move that particular data. So let me copy this particular path. This is the target path, and what I need to do, I need to copy the source path. Okay, so this is the file. This is the file, and the file name is ranking dataset .csv, rank underscore data .csv. Okay, and Hadoop fs-put, that is utilized in order to move this particular data on this particular location. This is the source path, this is the target path. So let me copy this and paste it onto the Hadoop terminal. Okay, so let's have a look inside ranking. I just want to see what is available. So the rank data set we will be able to see over here. So it has been moved to HDFS. Now the data is available inside HDFS. Let me mention the steps. Move the data. That is nothing but rank underscore data set .csv. Move the data set into HDFS. That is the first step. HDFS. So we are okay with the step number 1. Then what we need to do, we need to create a table. So creation of the Hive table. Creation of Hive table. So we are going to create the Hive table. Just have a look onto the columns or the data which is available inside rank underscore dataset.csv. Okay, so in this particular data, what we are having the name and what I can say the amount. Okay, so name and amount is there, and these are the two columns in this particular data set. So what I will do, I will create a table on top of this particular data. So in order to create the Hive table, creation of Hive table, what I will do, create external table, and what I will do, rank data set. Okay, that is the table. Over here what I'm having, name, that is of string type, and amount, amount is of integer type. Perfectly fine. Now can someone tell me what is the external table?
external table, we can store the metadata in the RDBMS, and the actual data we can store in the HDFS. When we are applying to the drop table command, then the only the metadata we can lose, but the actual data it's available on the HDFS. We can easily work on the actual
Yes,
data.
yes, yes. That is the beauty of external table. Huh? If we fire the drop table command, then the metadata will be deleted. The actual data will remain same. Okay. So we are going to create external table that is having two columns: row format delimited, fields. This is the CSV file. So the terminator, what it will be?
Fields terminated
Comma,
by comma.
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 Comma. Perfect. Huh? Fields terminated by comma. Stored, I'm going to store it as stored as text file, and location I just need to mention. And what is the location for this particular table? This is the location. So location is this one, and what I will do, I will mention it in this particular way, semicolon. Perfect. Let me create this table onto the Hive terminal. So this is the Hive terminal. Show databases. So we are having batch 32 boost. Let me use boost analytics at this moment. Okay, and here show tables. So these are the tables which are available inside the boost analytics, and let me paste the command in order to create the table. What is rank dataset in create a table? What is the issue?
Table 2 times.
Table is given two times. Perfect. Good catch. Okay, so table has been created. Show tables, and we are having this rank dataset table. So select star from rank dataset, limit say 5 or 4. Okay, so these are the records. Rank dataset name John Albert Mark Frank Lupa. Okay, and this is the same what we have seen over here. This is the same stuff. These are the same records what we have seen, but over here this is in CSV format, and inside the Hive we have created a Hive table, that is the Hive external tables. And just have a look over here. So describe formatted, and the table name rank underscore dataset. Okay, and just have a look over here. So this is the external table what we have created, external table, and this is the location of the data. Okay, where the data is stored. So user cloud era ranking, this is the location where the actual data is available. We are not talking about metadata. Okay, and these are the columns. Say name is of say string type, amount is of integer type. So this is somehow a little bit description about the table which we have created. Now what I'm going to do, we are having this particular table, and on this particular table I'm going to apply the ranking mechanism what we are able to see over here. So we have created we have moved the data inside the HDFS, that is Hadoop distributed file system. Inside the second step, what we have done, we have created a Hive table, and that is having the records which is available onto the HDFS. Inside the third step, what I'm going to do, applying ranking mechanism. Okay, applying ranking mechanism. So once we are talking about ranking mechanism, so we are having four types of mechanism or four types of ranking. So first we will proceed further with the rank, and then we will see what is happening over here. So say select the name comma amount what we are having. So we are going to select both of these two columns which are available inside this particular table. Select name comma amount, and what I'm going to do, I'm going to apply rank over what, over say order by amount, and I just want to have in descending order, DSC as rank from this rank underscore data set table. Okay, so let me explain what we are going to perform. I'm going to select both of these two columns, okay, which are available inside this particular data set. Then I'm going to apply ranking. That is, rank is the function which we are going to apply. And over what, rank is applied over what, I just want to have the ranking based upon the amount, amount, and I just want to have the amount in descending order. And what I will do, after getting the ranking of based upon amount, I am going to give the column name as rank, and it is from the rank data set, it is from this particular table. So let me copy and paste this particular command onto the Hive terminal. Okay, so what is the issue? Rank state. Okay, let me check. Things are looking fine. Missing EOF. What is the issue? Okay, I think this is the issue. The comma was missing. Okay, the comma was missing, my friends. So this will be the third column, and we have not separated it by with comma. So this comma was missing, and that was creating an issue. So what we are going to have, we are going to calculate the ranking based upon the given data set, and what will be the outcome? Just have a look. So this is like what is happening. We are having one mapper and one reducer. So the calculation is keep on going, and just have a look. So let me copy it and paste it over here. So what we are having, ordered by amount. So definitely it's ordered by amount in descending order. So the bigger one is onto the top and the smaller one is at the bottom. So this particular clause is working perfectly. Now what the rank function is going to provide, so if say we are having for 1500, so it is going to give first rank to all similar values. Okay, first rank or same rank to the equal values, it is going to provide same rank to the equal values, and ranks are not consecutive in nature. Okay, what we are able to get with the ranking function, it is going to provide same rank to equal values, and rank is not consecutive in nature or continuous in nature. In nature, it is not in continuity. So say first rank is there, then we are having fifth, we are not having sixth, then it's 7, 8, 9, 10th, then 12th is there, 11th is not available, 13th is not available, we are 14, 15, 16. So rank is not continuous in nature, and same rank is given to the equal values. So 1500, all the 1500 are having the same rank, all the 1300s are having the same rank. Over here all the 800s are having the same rank. So what we are able to get with the help of this rank function, we are, it is going to provide the same rank to the equal values, and it is not continuous in nature. So that is with respect to the rank function. Okay, applying ranking, so we are talking about rank. Now that is perfectly fine. Like with the help of rank function, we are able to get this particular outcome. Now we are having the another mechanism in order to calculate the rank. So the second one is dense rank. Dense rank. So what it will do, dense rank. So what the dense rank will do, it is going to provide same rank to the equal values, but the ranking is in, the ranking is continuous in nature. Just have a look, and then you will be able to get the outcome. So instead of rank, I'm going to apply dense rank only, dense rank. And what it will do, it is going to provide same rank to the equal values, and rank is continuous in nature. Okay, so that is the difference between rank and dense rank. Just have a look, and I'm going to copy and paste it onto the Hive terminal, and just have a look. You can track this particular job from this particular job tracking URL, where you will be able to get all the logs what exactly is happening in this particular query. Okay, so we are having one mapper, one reducer. Soon it will be executed and we will be able to get the outcome. Okay, so the mappers has been completed 100%. Now it came to reducer, that is also completed. And just have a look. Let me copy and paste it onto the notepad. Okay, so what we are able to see, same rank is given to the equal values, but the rank is continuous in nature, like 1, 2, 3, 4, 5, 6. It is not like what we got in rank mechanism. Over here the rank is not in continuous nature. Like one, then fifth is there, then seventh is there. It is not continuous in nature. So this is the outcome with respect to the dense rank. Dense rank. And sometimes it is being asked during the interview, like how you will be able to find out the second highest salary from a particular given data set. So second highest salary, at that moment you can apply dense rank, and uh, then you can select rank 2. Okay, so at that moment you will be able to get the second highest salary. Right. Over here if you are applying rank, then you are not having the information like which one is the second highest. Okay, so you need to choose these particular mechanism as per the requirement, and then you will be able to solve the queries in a better way. Then the row number. The next one is row number. How you will be able to apply or how you will be able to get the ranking based upon the row number. This is the third category if we are talking about ranking mechanism. So what will happen, let me copy this particular command and I'm going to replace dense rank with the row number, and what it will do, the row number is going to provide the ranks in continuous nature, like based upon the number of records. Like say if Leo based upon say 1 2 3, so it is going to provide, it is going to give one unique rank to each and every value. Okay, it is not going to check is it equal or not, it just provide a rank to each and every value based upon the given data set. You can say we are having one function that is monotonically increasing the IDs or provide me the numbers in monotonically increasing orders. That is nothing but we are going to have one value with respect to each record. So we are having this particular record, and what will it will do, the we are talking about row number, so it will provide a number to this particular record. Then we are having second record, it is going to provide the second number to that particular second record. Just have a look, then you will be having the better understanding. What has happened, row number, okay, so brackets were missed. Let me copy it again and paste it. Okay, so the execution has been started. We are having one reducer and it is going to provide me the ranking in continuous nature. It is not going to check the values or data. As per the record, it is going to provide one rank. So just have a look over here what it has done. So we are having first record, it has given one rank, second record, second rank, third record, third rank, fourth record, fourth rank. Over here 16 record, 16 rank. It is not going to check values and all, just it is going to provide the rank. Okay, rank to the values. So sometimes we need to have like how many records, or like we just need to add one number to each and every record, and this particular number we are going to utilize in order to differentiate these particular records. Like say the same records, say Leo 1500 and again Leo 1500 is there, but how we will be able to differentiate these two records, same records? Then you can utilize row number, and by utilizing row number you will be able to have, you will be able to get or differentiate the similar records which are given in a particular data set. Okay, so that is nothing but the simple stuff with respect to the row number. Moving further, what we are having, the fourth condition or the fourth uh, type of ranking what we can get, that is nothing but the partition by. Okay, so partition by, partition by. So over here, although like what we used to do, say we are having certain group, so what I can say, Leo, okay, so what you are able to see over here, say Leo is there, that is onto the rank 14, and Leo is there onto the rank first, and what we are having say John, that is given thrice. Okay, John is available over here. Okay, John is available over here. So what we are having certain repeated names. So what I can say, this is nothing but a group. John is one group, Leo is another group. So if we need to get the ranking with respect to a particular group, then how it can be possible? You can think in this particular way, like previously up to so far, like up to row number, what we are doing, say we are in a particular school, and based upon each and every class we are going to calculate the ranking. We are talking about the class only, yeah. Say it might be first standard, second standard, third standard, or eighth standard. So we are talking individually about a particular class. Now I'm talking about a particular school, say it is having certain class or sections. Now I just want to find out the top three positions or top four positions, or I just want to find out the ranking based upon the class, so that is nothing but a group. Okay, so in order to find out the ranking from a particular group, what we can do, we can add partition by clause over here with row number, and I will get the outcome, the required outcome, what I can say. Just have a look, then you will be having the better understanding. So partition by. Okay, so what I will do, I will copy this particular statement query and paste it over here. So select name, amount, row number, and over, what I will do, partition by name, partition, that is nothing but group by name, order by amount descending as rank from the rank data. So that is perfectly fine now. Let me try to copy this particular command and paste it onto the Hive terminal. Okay, the execution has been started, and just have a look, you will be able to get the outcome. At this moment we will be having ranking based upon the group, what I was what I was talking. Okay, so like if we are having different classes and we just need to find out the ranking based upon the classes, then how it will be possible? So you just need to add the partition by clause, and based upon the partition by clause you will be able to get the required outcome. Just have a look, my friends. Okay, so let me copy it first, and then we will have the discussion onto this, okay, so just have a look. Albert, it is not having repetition. Bart is not having repetition. Frank is not having repetition. Now John, just have a look, John, 1500 is having first rank, 1300 is having second rank, and 900 is having third rank, Lisa, 1500, that is first rank, and 900 that is second rank. Leo, the single record, first rank only. Lupa, first rank only. And Leo over here, say 1500 is having first rank and 700 is having second rank. So what we are able to see, based upon the groups we will be able to get the ranking, and it is utilized a lot. So partition by clause with row number is utilized a lot, because we just need to work onto the complex data, and based upon the complex data we just need to have the ranking from the grouping as well. Okay, so inside the industries we used to have partition by clause, and that is utilized a lot. We are having certain use cases of row number, rank, and dance rank, but those are like somehow less than to the partition by and row number clause, so that is with respect to the ranking mechanism, my friends. If you are having any doubt, you can ask. Just think for a minute and ask if you are having any doubt, all of you.
Yeah, so in the last example, this partition by category,
Mm-hmm.
this is only ranking those categories where it is able to partition on the basis of like on the basis of name. For rest, like in Albert case, it is 1500. In Bert case, it's 800. it is not ranking this like, because first three records are not in descending order. So it is
Actually,
only applying
over
the order
here,
on the group.
over here, the ranking is worked based
Group
upon
only.
the group only. Huh? It is not
Yeah,
like with respect to all of the records. Huh?
right.
Okay,
Mhm.
okay. So over here, it is working based upon the group only,
Right,
right?
right, right, fine.
Okay, perfect. Huh? Anyone else having any doubt? Pankaj, Mukesh, Vikas, Naresh, Paras,
No,
Gaurav,
Ashok.
Rohit.
Oh, no.
No, no, Ashok.
Perfect. Huh?
No, sir.
Perfect. 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 Okay, so we are talking about syntactic sugars, and the first stuff inside the syntactic sugar, what we have seen, ranking. Ranking. So inside ranking, we have seen these particular four categories. The second syntactic sugar, what we are having, shorting. Shorting. Okay. So shorting, as the name is indicating, we are going to short the data. Okay, short the data in ascending or descending order. So let me proceed further with shorting. Okay, so once we are going to talk about shorting, hmm, okay, shorting. So shorting is nothing but like shorting, aligning or arranging the data in ascending or descending order. Over here, what we have seen, order by. Order by is going to do what? It is going to shorten it in this particular data in descending order. Okay, so order by amount in descending, that is nothing but shorting is happening over here. So once we are talking about the syntactic sugar technique, shorting, so it is also like of for type. So what we are having, order by, short by, distribute by, and cluster by. Okay, so distribute by and cluster by. So these are the four techniques or categories of short. Based upon this, we will be able to short our data. Okay, so in order to proceed further with respect to the shorting, what we are having certain data set. So the data set with respect to this, what I will have, let me check. Hmm. Over to txt. Okay, so let me check. This is certain data set like AA1, BB1, DD5, EF2, TEH1, DTH4. This is like you can take name and the value. Okay, and don't be santy with the data set, like it is going to just provide you an insight how the shorting will happen. Okay, so order.txt, this is the data set that we are going to leverage in order to short our data, and then we will have discussion like what exactly is happening in these particular shorting techniques. So let me proceed with the order by. Okay, that is the first technique, and we have seen it. Order by. So order by, so there are certain steps once we are going to proceed with order by. So steps, and once we are talking about steps, then what I can do, I will create a table, and then I will load the data into this particular table. So let me create the table based upon this particular data. Mhm. So let me open this once again, and what I will do, I will mention say name. So step number 1, creation of Hive table. So create a table and say sorting data, and what I will do, I will mention say name, this is of say string type, and uh, hmm, and what I will mention this, say ID, what I can say, order ID. So sorting data, or this is the order txt, order txt. So order ID, order name, and ID, what I can say, order ID, and this is of say integer type. Perfect. So raw format delimited fields terminated by comma. Okay, now I'm having one question for you all. So this is the text file, order.txt, order.txt, and I have used fields terminated by comma. Why? Can someone tell me? This is the text file, order.txt. Guys, are you able to hear me? All of you?
Yes, yes. So
So
basically, we are
why?
using for CSV these things, but
No, no,
this is
no,
the
no, no,
first.
no, no. Yeah, for
Okay,
CSV, fields terminated by comma, that is perfect. But
yeah,
why we
and
have used?
inside
Why I
the
have?
inside the database, the value and the ID we have to segregate between. We are using the comma. That's why. Might be.
Just
Hello.
have a look onto the data set itself, na.
Yeah, yeah,
AA comma 1. So
yeah.
fields are
That's why
terminated by what? Comma. Although this is the
comma.
text file, but the field terminator is what? Comma only, na.
Comma. Okay. Hmm.
So
That's the
simple,
same thing.
right?
Same thing. I told. Yeah.
Okay, perfect. So name string, order ID is of integer type, row format delimited, fields terminated by comma, and I'm going to store it as a text file. Store as text file. We will be having discussion like why I'm going to mention it as text file. Okay, I can mention it as CSV, I can mention it as ORC, different file formats are there. So we will be having discussion onto the file formats as well. Now is this the external table, huh?
Manage table.
This is the managed table, huh? Perfect, huh? So this is the managed table, huh? And what is the managed table?
Metadata and both actual data will be lost if we fired a drop table command.
What? Yes, 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 that is fine, huh? Stored as, huh? My mistake, huh? Stored as. So it was throwing error. So the table has been created, huh? Show tables, and what we are able to see, sorting data, huh? That is the table what we have created. So just have a look, select star from sorting data. Okay, sorting data. Will this table have records?
No, we need to insert.
Yes, because this is the blank table, we have not loaded the data. Okay, so what we need to do inside the next step, in the next step, we need to load the data. So step 1, creation of the Hive table. Step 2, loading the data into Hive table. Okay, that is the step 2. So I'm having this particular table, oh sorry, file, which is placed onto the local of my machine. So what I will do, I will load the data by mentioning the command load data, load data. Speak with me.
Local in path. Local in path.
Local in
Local in
path.
path, local in path, local in path, and we just need to mention the source path into table what? Into
And table sorting data.
table sorting data. Okay, perfect. And I just need to copy the path over here. So orders.txt, this is the table. Let me copy this and paste it over here. And I just need to mention the file name. The file name. Okay, perfect. Let me copy this particular command and run it onto the Hive terminal. And the data has been inserted, and now I'm going to run this command and just have a look. We are having records inside the sorting data table. Sorting data dot name, this is the field which we have created, and sorting data dot order id, this is the you can say the order id which we have created. Now what we are having this particular data. Okay, we are having this particular data. Let me copy and paste it over here. So the table has been created. Sorting underscore data, this is the table records. Okay, now what we need to do in the third step, we need to apply the sorting mechanism. Okay, applying sorting mechanism. Okay, so in order to apply sorting mechanism, the command is very simple. What we need to do, we just need to say select, and what I'm going to select, say the order id, select order id. Okay, order id from what? From the sorting table. Sorting data is the table name. Sorting data. Let me copy in order to avoid ambiguities. Okay, sorting data and order by just the order id. Okay, order id, you can select the name as well over here if you want. So let me try to copy and paste it over here. Okay, so it is very simple, like you are just going to perform the sorting based upon the order id, and you are selecting the order id only. So the execution has been started, and we are having one reducer and one mapper, and just have a look. So the sorting has been done, and what we are able to get the outcome. By default, it will be in ascending order. So that is not an issue. So we are able to show the data whatever we are having, and it is the outcome. Now you just need to pay attention over here. So order by clause is going to perform 100% sorting of your data, sorting of your data. Okay, it is going to perform the 100% sorting of your data, as only one reducer is being utilized over here, utilized over here. Okay, moving further, I will come on to this particular point. No need to worry. The second technique is short by. Short by. So once we are talking about short by, then it is similar to order by. Let me mention it is similar to order by. Once we are having one or single reducer only, but once we are having more than one reducer, then short by clause will not guarantee 100% shorting of your data. Okay, okay. So short by and order by, these particular clause are similar to each other once we are having single reducer. But once we are having more than one reducer, then short by clause is going to provide you the different outcome. Just have a look. So over here, what I will do, I will first proceed with the short by. Okay, let me apply the short by clause instead of order by. Short by, and just have a look. You need to pay attention over here. So number of reducer, that is 1. So if the reducer is 1, then we will be able to get the similar outcome what we got in order by. Okay, just have a look. Okay, so this is the outcome. Once if we are talking about short by, copy, and let me see here. Okay, last one is 12 over here. The last one is 12. Okay, 6 6 5 4 3 2 1, and the same stuff we are able to see over here. So because what is happening over here, we are having single reducer only. We are having single reducer only, and once the reducer is only one, then order by and short by, both of these two clauses are having the similar output. Now in order to validate, what I need to do, I will try to change the number of reducer. Okay, so in order to change, set mapred dot reduce dot tasks equal to say 2. Okay, I'm going to have two reducer, and set there are certain other properties. Set hive dot executor dot reducers dot byte dot per reducer, what I can say 250 or say 300. These are the bytes per reducer, and set hive dot executor dot reducer dot max equal to 2. Okay, so I'm having certain properties. These are the certain properties which I am going to set, and another property is also there, set map reduce dot job dot reduce equal to 2. Okay, set map reduce dot job dot reduce. Let me try to set this property. So first of all, uh, let me show you something. So this is the property which I have discussed in previous session as well. Set map reduce job dot reduce. Okay, so let me copy these parameters. I was talking about these properties in previous session, right? Are you able to recall, all of
Yes,
you?
yes. Yeah, so
Okay, so I was talking about these properties in previous session, and at that moment I told that we will be going to utilize these particular properties in order to change the number of reducers and all for the understanding perspective. Okay, so these are certain properties which are given in each and every command which we are going to execute in Hive. So let me try to get the values. Okay, so the value for this particular property is set to 1. Okay, if you are able to get the information, so map reduce job reduce, that is 1, and byte per reducer. Okay, so these are the bytes. As we are having very small data, this is around 25 MB. Okay, so I'm not going to like move with much data, so I'm going to move with 300 uh, bytes only. Okay, these are the properties, and set hive reducer max executor reducer, so it is also set to 1. Okay, so maximum is set to this one. Like if you can reduce, like we can have this much of reducer. You can increase or this decrease this particular number. So we are going, no, we are not going to change this particular number. So I will be going to change these particular properties. And map reduce job dot reduce, and just have a look how many reducers are there. So it is undefined at this moment. So let me try to to set these properties. Let me try to set this one only. Okay, so job reduce dot task. Map reduce dot task equal to 2, and map reduce job dot reduce to 2. Okay, I'm going to change these two properties. Okay, so I have changed these properties. Now what I will do, I will execute the same command which I have executed in the previous execution. So short by, just have a look. Now the reducers are set to 2. Just have a look. The num reducers are set to 2. Guys, are you able to see? All of you?
Yes,
Yes,
Ashok.
So
yes,
previously
Ashok.
the perfect, perfect. So previously the number of reducers was 1, only 1. Now what we have done, we have changed the number of reducer, and if we have changed the number of reducer, then the sort by clause will not provide you the 100% sorted output. Let me copy. So we have executed the same query, and now just have a look. So this is the outcome what we got from the first reducer. Okay, with the help of numbering itself, like first, second, third, fourth, fifth, sixth, and 12th, this is what we got from the first reducer, and this is what we got from the second reducer. I can differentiate it, because we are having two reducer. If we are going to set the three reducers, so probably we will be having three blocks, say 1 2 3 and then 12, then 1 2 3 and 12. Okay, in this particular way, so we will be having different blocks. This is as per my understanding. So what I'm getting, like, this is the outcome. This one is from the first reducer and this one is from the second reducer. So the data set or outcome is not 100% shorted, right? Are you with me, all of you?
Yes, yes.
Perfect, no? Fine
Yes,
so
yes,
far,
Ashok.
all of you?
Yes, yes, yes.
Yes, Ashok.
Perfect. So the outcome is not 100% shorted once we are going to leverage short by close and we are working with more than one reducer. The data, the output result is not 100% shorted. However, once we are having same number of reducer, like only single reducer, then order by clause and short by clause are having the same output. That's what we have mentioned over here. It is similar to order by once we are having single reducer only. Okay, so order by equal to short by with one reducer. Once we are having more than one reducer, then short by is going to provide the different outcome and the output is not 100% shorted. That is the difference between order by and short by. You can think in this particular way as well, like say we are having mapper 1, mapper 2, mapper 3, mapper 4, mapper 5. Okay, so we are having these many mappers, so these are nothing but machines, what we are having in order to process huge amount of data. Now if these particular machines are giving the outcome to reducer 1 only, then you will got 100% shorted outcome, right? Okay, because the entire data is given to this particular single machine. Okay, or component, what I can say, it is going to short the data and the shorting is 100% at this moment. So either like we are using order by or short by, the outcome will be same at this moment. Now once we are going to have the two reducers over here, reducer 0 and reducer 1. So so what I will be having, it is going to provide its own output and it is going to provide its own output. So the outcome, if we are going to leverage short by, it is not 100% shorted. Now you will be having one assignment. What do you need to do? Okay, apply order by clause while setting reducer equal to 4 and provide your comments. is the data set 100% shorted or not? Are you able to get the statement? All of you, are you able to
Yes,
get
Yes,
what I have asked?
yes,
Okay.
yes, Ashok.
Okay. So this is this you can take as an assignment, and you can share the snapshot over the chat window, or you can share the query onto our Slack channel. Okay. So what we have seen with respect to the shorting, we have gone through with two clause, that is order by and sort by. Moving further, what we are having, the third clause, that is what? That is what? That is distribute by. Distribute by. The third clause for shorting is nothing but the distribute by. Distribute by. So over here, friends, what you are able to see, uh, say the reducer 1, this is the reducer 1 and reducer 2. What we are having? We are having overlapping output. Say 1 is available over here, 1 is available over here, 2 is available over here, 2 is available over here. 3 might be, all of the records are overlapping in each and every reducer. So how to solve this particular issue? So what I need to do, I need to apply the distribute by clause. So distribute by clause, what it will do, it will ensure that each reducer get non-overlapping set of values. It is not shorting the data oblique records. Okay, so just have a look. This is the query what we have executed, and select order ID from shorting data, and what I just need to do, instead of order by, I just need to mention distribute by. Okay, distribute by order ID. Perfect. Let me copy and paste it over here. Okay, so number of reducers are set to 2 only at this moment as well, because we have changed it in the previous execution and it will remain same. Sorry. And just have a look. So let me copy this and it over here. So what I have mentioned, distribute by is not going to short your data. So you are able to see, like, it has not shorted. 2 is there, 6 is there, then 4 is there, again 2 is there. Okay, but what it has done, so as per my understanding, like, this is from the reducer 1 and this is from the reducer 2. Okay, and these are non-overlapping values. If one is available inside uh, in this particular reducer, so one is not available over here. Okay, if 5 is available over here, sorry, then it is not the part of reducer 1. So this is the same like what we have mentioned over here. like non-overlapping values, and it is not going to short the data. Okay, so from the functioning perspective, distribute by clause is good because this is the same expectations, like no you can say repeated values or repeated keys will be there among the reducer. It will create certain challenges. So distribute by clause is good, and it is going to provide you the non-overlapping values among each and every reducer. So in another words, like what I can say, we are having uh, uh, even values over here and odd values over here. Somehow that particular random function is working over here, and based upon that we are able to get the outcome. Right? Distribute by clause. Is it fine with everyone? Distribute by.
Yes,
Say
yes,
yes
Ashok.
or no.
Yes.
Yes, Ashok.
Yes, Ashok.
Perfect. So the last sorting mechanism what we are having, that is the cluster by. Okay, so the cluster by, and cluster by, it is the combination of short by. It is the combination of short by and distribute by. Okay, so over here the best part from this distribute by, like we are having non-overlapping values, but it is not providing me the outcome in the shorted way. And the best part with respect to the short by, it is providing me the outcome in the shorted fashion, but having the overlapping values. So what I'm going to do, I'm going to take the benefit about these particular two techniques. I will combine these techniques and mention as cluster by. So it will be the combination of both of these two. I will be getting non-overlapping values in shorted fashion. Okay, the desire or the the stuff what I want non-overlapping value in shorted fashion. Non overlapping values in shorted fashion. So that is the desire. So if I want to have this, then I'm going to combine these two techniques. And how I'm going to write the query, let me copy this, paste it over here. So from order, distribute by order ID, and short by, I just mentioned short by the order ID once again, and I will park it under the cluster by. So just have a look. I will copy this and paste it onto the Hive terminal, and that's it. So the execution has been started, and we will be having two reducers over here as we have discussed. Okay, two reducers. If you are able to see, just focus into the cursor. I'm hovering over here. And it will provide me the outcome non-overlapping of records in the sorted fashion. So just have a look. Soon we will be getting the outcome, and it's there. So let me copy this and paste it over here. Okay, so this is from the reducer 1, and this is from the reducer 2, and now it's shorted in nature. We are having non-overlapping records which are shorted in nature as well. So that is with respect to the cluster by clause, and it is nothing but the combination of short by and distribute by clause. Just have a look, my friends, and ask if you are having any doubt. Anything that you want to ask? Huh? All of you. Is it fine with everyone?
Yes, Ashok.
Yes,
Rohit,
Ashok.
Fine.
Gaurav, Pankaj, Swati,
Yes,
Mukesh,
fine. Yes.
Vikas, Naresh,
Yes,
Paras.
Ashok.
Perfect, Dana. So try to do the practice, whatever we have discussed in today's session. Tomorrow we will be having some more syntactic sugar techniques, and then this hive will be over, and we will proceed further with PySpark. That is Python plus Spark. And before that we will be having discussion about some file formats and all. So that is those are the small topics. Those particular topics will not take time. Our main focus into the Python and PySpark, so that will be started from the next week onwards. So that's it for this particular session, my friends. Take care, have a good day. Let me stop recording.